times by the cash flows in 208 days. You can see now the only thing we don't know is the discount factor in 208 days, and we can do some mathematics to calculate that discount factor. Let's simplify the problem. Now what we're going to do is subtract 1.7370 from both sides and then divide through by 1011.875. So the discount factor for 208 days is going to be equal to 988.4375 minus 1.7370, all divided by 1011.875, which equals 0.9751. That's the discount factor for 208 days. We can use the same technique used to calculate the 27-day discount factor and the 208-day discount factor to calculate discount factors at 392 days. So exactly the same approach. We do the same for 573 days. And we can do the same for 757 days. The result is that we've used 5 government notes or bonds to calculate 5 discount factors. We can now use these discount factors to price the 3% note that matures in 757 days. All we need to do is calculate the present value of the future cash flows. And we know that at 27 days we're going to receive $15, but we know that there's accrued interest there. So if we want to calculate the clean price, we're going to do the discount factor for 27 days times by how long we own the bond for, which is 27 out of 184 days, times by the coupon payment, which is 15, plus the discount factor for 208 days, which is 0.9751, times by the coupon, plus the discount factor for 392 days, which is 0.9538, times by the coupon of 15, plus the discount factor for 573 days, which is 0.9342, times by the coupon of 15, plus the discount factor for 757 days, which is 0.9149, times by, well, here we get the principal and the coupon, so 1015. And if we do this calculation, I get $973.764. That's the present value of the 3% note maturing in 757 days, after accounting for the accrued interest. What do we need to get the quote? To get the quote, first of all, we need to put this in percentage terms. So as a percent of $1,000, it's going to be 97.3764%. We've now got to convert this decimal into 30 seconds. So we're going to do 0.3764 times by 32, which is approximately equal to 12. The quote that we would see in the Wall Street Journal would be 97.12. That's bootstrapping. We have just priced this note using bootstrapping. Now let's compare our valuation approaches. In the last video we used strips. In this video we've used bootstrapping. And we've calculated prices using both approaches. The Wall Street Journal said the price was $97.11. Using strips we find the price is $97.13. And using bootstrapping we find the price is $97.12. In theory, the prices should all be the same. And that would mean that the discount factors should all be identical. In fact, the discount factors aren't quite identical. If we look in each period, they're not the same. They're close, but not identical. Remember, we talked about transaction costs. This may account for some of the differences. But these discount factors are identical to 3 decimal places, and we will see that the prices that result are very close to the Wall Street Journal price. The discrepancies between the prices and that quoted in the Wall Street Journal arise because of the market frictions. Remember, we have to deal with bid and ask prices. We also have to pay commissions fees to brokers. All these frictions will mean prices will be slightly different using strips, using bootstrapping, compared to the Wall Street Journal price. You could use the strip approach or the bootstrapping approach to identify arbitrage opportunities. But you have to take into account transaction costs. The prices that we're seeing here suggest there are no arbitrage opportunities when we compare to this price that's quoted in the Wall Street Journal. But we have computers every day that are looking at all the bonds that are out there, all the government bonds, and trying to identify mispricings that, even after taking into account transaction costs, can be exploited to make money. The fact that we have computer programs that are constantly searching for these mispricings mean that as soon as a mispricing occurs, it's very quickly eliminated via an arbitrage trade. That means that the prices we see are going to be very close to their true values all the time. It's going to be very hard to find arbitrage opportunities in the US government bond markets. What happens if we're trying to value non-government bonds? The strip pricing and the bootstrapping methods are there for treasury notes and bonds, but there's no default risk with treasury notes and bonds. With corporate bonds, we've got default risk. If we use discount factors that contain no default risk, then we're going to get mispriced corporate bonds. So do you think the corporate bonds will be overvalued or undervalued if we use these discount factors based on government bonds where there's no default risk? If there's default risk, you'd think you'd require higher rates of return. In other words, your discount rates will be higher, which would mean your discount factors would be lower. So if we use these government discount factors, the corporate bonds are going to be overvalued. We need to lower the discount factors to reflect credit risk. How much you lower these discount factors is a complicated problem. We're not going to cover that in this class. If this is something that interests you, the pricing of credit risk, then you should be taking the fixed income class here. That's all I wanted to cover in this video lecture. We have now seen how to price government bonds using strips or using bootstrapping. See you